So what I'm going to do, like I said, is kind of go fast through the why all the ordered pairs are what they are in the unit circle. But tomorrow we're going to kind of stop and really slow down. And I'm not going to teach anything new tomorrow. I'm going to go over course offerings tomorrow, because I know if your fourth period teacher had checked their box, they should have given you your pink course offering sheet. If they didn't, please try to ask your fourth period teacher for it tomorrow. But I'm going to go over all your options for next year and the whys and whats of what all the different classes are and give you more information about that. And we're going to get a pink unit circle for you guys to all fill in as your key that you'll keep in the front of your notebook. And we might even be ready for some head-to-head competitions at that point. We'll see. I do a lot of those I try to make it fun, where you can go head-to-head against each other and I'll give candy to the winner or something. And I've even gone head-to-head with students. No one's ever beat me, even Mackenzie Shackton. But she's always the best. She's always beaten every student that I've had with her timing. But, we'll see who maybe the superstars are. Anyway, don't stress about that. That's just optional. It's for fun. Okay? So what we started with last week was like all the vocab, like initial side, terminal side, theta, things like that. Okay? So what I want you guys to look at here is this zoomed in picture basically of this angle right here. Okay? So this is just the X and Y axis. This is a quadrant 1 angle where theta is at the origin, so that's right here. Okay? There's your initial side, your terminal side, and then what is drawn dotted there is if you drop down from your point to the x-axis, it makes a right triangle. And so what I'm going to go through pretty quickly here in a minute is that the unit circle is made up of just a bunch of right triangles, okay? And what they all have in common is the hypotenuse of that right triangle is the same as the radius. And it's always going to be 1, because that's what it is on the unit circle, unit meaning 1, all right? And then we have theta here, and theta will always be, a triangle has 3 angles, right? All triangles have 3 angles. The theta is always the angle by the origin. It'll never be anywhere else. I'll never say, oh, now we're going to call that theta, or we're going to call that theta. Theta is always the angle that's by the origin, okay? And in relation to this theta, you have an opposite leg, you have an adjacent leg, and you have the hypotenuse, okay? And the radius and hypotenuse are the same thing, because the radius is just from the center to any point on the circle, and for us, it's also the right hypotenuse of a right triangle, okay? And there's something called SOHCAHTOA, and every year that I teach this, it hasn't happened yet, there's somebody that's never heard of that. Is there anybody in here that's never heard? I mean, you don't have to tell me what it is, but you've heard of it, like somebody in your life before me has said that phrase to you, that acronym. Is there anybody that hasn't heard it before? It's okay, I won't judge you. Okay, SOHCAHTOA, but from here on out, I'll just write it like this. SOHCAHTOA is where we come up with the sine and cosine, which is your x and y, I'll teach you in a second, of all of the ordered pairs. And it comes from opposite leg over hypotenuse and so on. So I'm not going to go through all that, because here's the thing. The unit circle, like I said, is made up of a bunch of these ratios, but you don't ever have to do them after right now. You just know them, because they're just the same thing repeated over and over and over again, okay? But we will move off of the unit circle and just do any right triangle, and we'll come back and revisit all of these more in depth. So here it is, zoomed out now. We're looking at that angle, right angle there, made with the x-axis. Theta is at the origin. Our radius or hypotenuse is 1, okay, and P is a point on the circle. And in algebra, we call all of our points x and y. But in trig, we call them cosine theta, sine of theta, okay? And if you didn't ever realize it, x and y are in alphabetical order, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. That's alphabetical order. And so is this. Cosine comes before sine. And that's what one of the things we're going to focus on as we go through the homework together in a few minutes, okay? So basically, right now, we're just understanding right triangle. Cosine, sine makes up the point. And I kind of went over the basics. Now, where do the ordered pairs come from? I am horrible with geometry. I'm not good at teaching it, but real quick review of the special right triangles. Same stuff you learned long, long ago in geometry. Like I said, I'm going to go through these very quickly, but tomorrow we have a little bit more of a loose class period where I'm not like up there teaching. If you need me to explain any of this better to you because you really want to understand where they come from, please, by all means, I will. I will sit down with you and go over them better. But in a special right triangle, that's a 30, 60, 90. So here's a 30, 60, 90. We're going to talk about the side lengths. Well, in a 30, 60, 90 on the unit circle, your hypotenuse is 1. That's that radius. It's always 1, okay? And they have special relationships between the sides. The side opposite the 30-degree angle is going to be x. The side opposite the hypotenuse is 2x. And then the side opposite 60 is x square roots of 3. So knowing that, I can divide 1 by 2 to get my smaller side. So that'd be 1/2. So now look at it in reverse. If the side opposite 30 degrees is x, let's call it 1/2. If you divide it, did I say that right? Now I already feel like I messed it up. 2 times 1/2 would just be 1. And then if we multiply 1/2 by the square root of 3, we get square root of 3 over 2. So you're going to see these two numbers in a whole bunch of places. For example, let me just do one of them for you. If I said, what is sine of 60 degrees? If you go back to the other page, sine is opposite over hypotenuse. That would be, here's 60 degrees. Opposite would be square root of 3 over 2 over 1. So you always just get square root of 3 over 2 because 1 in the denominator doesn't change it. Now you're never going to have to do any of that. It's what we, bad word, memorize on the unit circle. But you'll see that in a second. 45, 45, 90s are easier if you remember. Hypotenuse is always 1 on the unit circle. And the two legs, these are called your legs, are equal because the angles opposite them are equal. And the ratio is these guys, their sides that are opposite them are x. And then this guy is x times the square root of 2. So if we're going in reverse, if I had x, I would multiply it by the square root of 2. I don't, so I'm going to divide by the square root of 2, rationalize my denominator, and that's where this comes up. Square root of 2 over 2, square root of 2 over 2. So again, if I do sine or cosine, it's adjacent or opposite over hypotenuse. Hypotenuse is 1. That's why you just see these values all on the unit circle. Okay? Now let's go through the 3 most common angles on there, 30, 45, and 60. So if theta is 30 degrees, they're giving you the ordered pair, x and y, right? But in trig, we call it cosine and sine. So what you'll see all the time is when you have to fill in some blanks of different trig functions, there's 6 of them, sine, cosine, tangent, cosecant, secant, and cotangent. Right now, we're only worried about sine and cosine. We're not even doing tangent today. We're going to do those tomorrow. Sine and cosine are always written in this order. Even though the order doesn't matter, what order you write them in, like when you go to fill in blanks, all the time sine is first, so I'm going to get you in the habit of putting sine first, and knowing that 1/2 is sine and cosine is square root of 3 over 2. That's the first mistake I want to point out that I see students make all the time is they mix up cosine and sine. Remember, in the ordered pair, it's always alphabetical. Cosine comes first, then sine. So you just have to make sure you fill in your blanks correctly. Okay, let's keep going. The 45-degree angles. Again, let's put sine first, cosine second. Right? This would be cosine, this would be sine. Doesn't matter because they're the same. On the last one, our 60-degree angle, cosine, sine. Just the point I'm making here, and we're going to do a whole bunch of these in our homework together, and I'm going to keep writing them in this order, is that you just pay attention. Don't just blindly fill in blanks in the order you see it there. Make sure you put it in the right place. Okay, that takes care of 3, 6, 9, 12 angles on the unit circle, and that leaves 4 more. And you may not realize we just covered 12 angles, but we did, and I'll show you how in a second. What's left are the quadrantals, and you'll see, I think it's your facing page, but quadrantal, spelled like that, quadrantal angles. I also call them the four corners. It's these four here. And so the question is, what is sine and cosine of 90 degrees? So 90 degrees, of course, is up here, right? Initial side, terminal side, wrapping that way, theta, whatever. What is the ordered pair for 90 degrees? Quick, what is it? Hannah, what'd you say? 0, 1. Yeah. Remember I told you, people mess up on those angles the most. When I grade your timed unit circle quizzes Wednesday, those are the ones I mark wrong the most. Okay? Sine is 1, cosine is 0. Just comes from that. And I'm going to go over all of those here in a moment. Okay? Now, what Jean Adams has prepared here for you is a chart that we're not going to use. In fact, I'd really love it if you crossed off what I cross off. Here's where I'm going to tell you a little bit about radians, but we're not filling this in because that's memorization. I don't want you to use a chart to learn the unit circle. I want you to use the circle to learn the unit circle. But I want you to know that every degrees has a radian. Remember, theta is measured two ways, degrees, radians. We had a formula last week that said we can change degrees to radians by multiplying by pi over 180. And the same thing in reverse, right? So multiplying that, we would have 30 pi over 180. 30 divided by 180, math, enter, enter. You get 1/6. So that's where they got pi over 6, right? 1/6 pi is pi over 6. So you don't ever have to do this math here. You're going to know these in just a minute. You will, okay? But every degrees has a radian. Same with the quadrantals. The quadrantals are those four. I know it's not really a corner, but I'll call them the corners. So take a look at that. All that is, remember the picture I drew you before, is just this circle right here, blown up. So none of you would mess up that this is 1, 0, and this is negative 1, 0, and that 0, 1, and that 0, negative. Okay? That's what you're looking at, the four points out from 0, 0. Okay? So you can see the radians there, but we're going to go over all of that on our unit circle. Now listen, here's the point. If your eyes have glazed over, you're annoyed about how hot it is in here, because it is hot, you don't want to be doing this. This is where you really want to pay attention. I'm telling you, students that were in my classes, maybe not first grade, but second and third, definitely left being like, oh, it's not that bad. I kind of get it. Or I remember it from the last teacher I had. Okay? Even if you don't remember it from last year, I got you. Now, this is my way of seeing the unit circle. I really, 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 really focus on quadrant 1. Because the truth is, if you know quadrant 1, you know all of the quadrants. Because quadrant 1 repeats itself as we go around, right? So let's start with where these radians come from. This is, besides the quadrantal part, so you get all excited, besides the quadrantal part that I told you people mix up the zeros and ones and negatives, right here is the first mistake. So I'm going to teach you how not to mess it up by relating it to something you guys are all very familiar with, and that's pizza. If I order 2 pizzas for this class, and one of them gets cut into thirds, so each piece is 1/3, okay? And then I cut one of my pizzas into, and pretend these are equal, okay? And I cut each of these into 6. And you're hungry, Ty. Which pizza do you want a piece from? Probably. Definitely, if you're hungry. My point is, which piece is bigger? This 1/3 is greater than 1/6. So if you're hungry, you want one of these pieces versus one of these pieces. I try to make 6 equal pieces. Is he really critiquing my drawing? I am an artiste, and I don't appreciate that. I don't. Do people go to the Dali Museum and say, "Well, Dali should have done this, or I would have done that instead of that"? So no, I don't want to look. You're focused on the wrong thing. 1/3 is greater than 1/6. Okay. Why do students get confused? It's very obvious. 6 is bigger than 3. Okay. But when you put a 1 over it, it's opposite. So be careful. So let me tell you what you're looking at when you look at this picture. You are looking at, you don't need to draw this, you just need to enjoy my artistry. You are looking at, in quadrant 1, you're looking at a bunch of special right triangles. We have one that goes out to here, drops down, that is a 30-degree angle, okay? You have another one that goes out, drops down, makes a right angle. That would be a 45-degree angle. You have another one that goes out to this point, drops down, makes a right angle, and that whole thing is 60 degrees. Well, guess what? Then we get to 90 degrees, and then it repeats going the other direction. Here's that 60-degree angle. I can't do them as well from I'm not really good at going this direction. I need to practice more. And this just repeats the whole way around, okay? You don't see those, but that's what you're looking at. So when we go out to pi over 6, that's also known as 30 degrees. This is 45 degrees, and this is 60 degrees, and then you get to 90 degrees, right? So no one messes up the degree order. No one thinks 30 is bigger than 60, but look where more confusion can come in. 3 and 6, 6 and 3. Degrees, just numeric. Radians, pizza. Pizza, pizza, pizza. Pi over 6 is smaller than pi over 3. Smaller to bigger. Let's memorize that. I said it. Memorize it. Okay? So now let's fill in the ordered pairs. Again, if anybody wants me to go deeper into this with them tomorrow, I will. But where the numbers are that I'm going to be coming up with here are simply from those little pictures I showed you. So in our first set of ordered pairs, we always start with the square root of 3 over 2 and then 1/2. And the 60-degree angle is that flipped. And we're going to do, when I do the homework with you, you're going to see how quick and easy you can get through these. Okay? So denominator of 6 is the first angle you come to. It's the smallest angle, denominator of 6. And it always starts with the square root of 3. Okay? The other one, the one we confuse it with, is that same thing flipped. And the ones in the middle are just square root of 2 over 2, square root of 2 over 2. So all of my middles are going to be that same green ordered pair. Let's go ahead and fill in the quadrantals. Remember, this is 0, 0, guys. So this would be to the right 1, up or down 0. This one up here is left or right 0, up 1. This one is negative 1, 0, and 0, negative 1. Remember, I've said this to you, that those are the ones people mess up the most, is those 4 corners, okay? And let's remember, everything in quadrant 1 is positive, right? All of your ordered pairs in quadrant 1 are positive. Now, when we go to quadrant 2, remember I said quadrant 1 just repeats itself? Here's how. All of your denominators of 3, and there's 4 of them, there's 2 there and there's 2 there, all of your denominators of 3 have the same ordered pair of 1/2 square root of 3 over 2. Another way of looking at it, besides that the denominators are the same, is that they are both, these angles, are on either side of the y-axis. This is going to repeat itself down here in a moment, okay? Same with the denominators of 6. They're all going to have the same ordered pair. If you're a denominator of 6, that's your ordered pair. And if you're a denominator of 4, you're going to be that really easy one that nobody ever messes up on. But what happens in quadrant 2 that's a little different? What's the only difference between quadrant 1 and quadrant 2? X is negative. Cosine is negative. Right? To go to the, we're at 0, 0, we're going into quadrant 2. To the left and up would be negative, positive. And with our degrees, because here's the thing, this is why I don't want you to memorize. Everything that I'm going to show you today is very common sense mathematically, especially for this class. There's all patterns. What we're doing with the degrees, starting at 0, is we're adding 30 to 0, adding 15 to that, adding 15, and then adding 30. And we keep going. Add 30 to 90, add 15 to that, almost forgot it, and then add 15 to that, and add 30. It's 30, 15, 15, 30. 30, 15, 15, 30, the whole way around. What is good news is that we deal with radians mostly in pre-calc and calculus. We need to know degrees, but it's not as much. And trust me, radians are easier. By the time we're done with this, I hope you'll agree with me. Okay, let's go into quadrant 3. All of my denominators of 6, remember, also they're the ones that are around the x-axis, have the same ordered pair. So above and below the x-axis will have that ordered pair. The one in the middle, you guys know what that one is. And then the ones by the y-axis will start with 1/2. What's in quadrant 3 that's different, though, for those ordered pairs? They're both negative. To the left, down. Negative, 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 negative. Degrees, there's that pattern again. Add 30, 15, 15, 30. Add 30 to that, we get 210. Add 15 to that, 225. Add 15 to that, we get 240. Add 30, you're at 270. Last quadrant, remember if your denominator of 3 or right next to the y-axis, however you want to look at it, you're going to have 1/2 go first. Middle guy, and then our denominators of 6 always start with the square root of 3. Quadrant 4, cosine is what? Positive. That's to the right. Sine is negative. Respect the coordinate plane. Respect your quadrants that you guys know like the back of your hands. None of you, if I gave you a quiz on graphing points, none of you would get them wrong. So don't think of this as anything else as points on the coordinate plane. Now, we've filled it out. Let's talk about some things that I want you to pick up on. First of all, let's review what I just said about the ordered pairs. Besides the sines and besides the quadrantals, the pattern. Watch my fingers. The two angles that are hugging the x-axis, so the two above and the two below, look, they're identical except for their sines. The ones that are hugging the y-axis, identical except for the sines. They also share the same denominator. All of my denominators of 3 have the same ordered pairs. All of my denominators of 6 have the same ordered pairs. All of my middle ones are the denominators of 4 and have the same ordered pairs. Okay? Degrees. In quadrant 1, we're all acute. They're so cute, they're less than 90, right? All less than 90. Look at what all of the ones in quadrant 1 have in common. They all start with 100. You get to quadrant 2, they all start with 200. In quadrant, they say 3. Quadrant 2 is 100s, quadrant 3 are the 200s, and quadrant 4, oh, I didn't do them. This would be 300, sorry about that, 315, 330, all the way up to 360. That was adding 30, 15, 15, 30. Quadrant 4 are all 3s. So just at a quick, if I said, what quadrant is 200, anything that's 200, and you know where it is. You know the ordered pair is going to be certain signs. You might have to do a little bit more work finding which one it is, but here's another thing to help you. All of my degrees that end in 5, the ones digit is a 5, there are only 4 of them. They're all your middles. Notice it, 45, 135, 225, 315. Those are your denominators of 4, the only ones that end in a 5. So that zeroes in on it a little bit more too, okay? Let's talk about radians. Quadrant 1 Now we know the denominators are repeating. 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. 6s, 3s, middles are 4. But numerators are really simple also. Quadrant 1, they're all just pi, just 1 pi. That's it. So pi over anything, quadrant 1. In quadrant 2, our numerator, top number, is 1 less than our denominator, bottom number. Subtract 1 from my denominator, I get 2. Subtract 1, subtract 1. Quadrant 3, add 1. 6 plus 1, 4 plus 1, 4 plus 1. But more importantly, not memorization, understand common sense math. This is 1 pi. This is important because we get these two quadrants confused a lot. People do all the time. Think about what I'm going to tell you right here. All of these angles, even though the ordered pairs are the same, they're getting bigger, right? 30, 45, 60 as we're getting bigger. So the radians are getting bigger too. All of these, all of them before you get to pi are less than 1 pi. And that should make sense. 2 pi over 3, that's not quite 1, right? That's a little less than 1. All three of these are just one numerical digit away from being 1, right? If this was just a 3 over 3, it'd be 1. If this was 1 more, it's 4 over 4, 1 more would be 6 over 6, we get to 1. So these are less than 1, so they come before pi, quadrant 2. Look at quadrant 3. These are improper fractions. So you could change 7 pi over 6 to 1 and 1/6, right? 6 goes into 7 one time, remainder of 1 over 6. So that's 1 pi plus a 6. This is 1 pi plus some more. 1 pi plus some more, right? It makes sense that these are after pi, aka quadrant 3. And I call quadrant 4 chaos, because it doesn't really have a great pattern. I'm sure you've heard it if you had Ms. Shackton. I don't know if she teaches it this way, but at 5 we go to 7, 11. That's just a little mnemonic. Is that the word? I'm not sure if that's the right word for that. A little mnemonic that helps me remember, because there's not a set relationship between the numerator and the denominator, like a difference of 1 with these. I know that there's all kinds of patterns you guys are going to start sharing with me, and I appreciate it. I love it, and any that you see, I love to share with my other students, because remember I said I'm going to throw things at you, not literally, until it sticks for you, okay? So we're going to take this information, and we're going to go to the homework together right now, and I'm going to show you exactly how, if you are nervous at all about this, if you buy into my way of doing it, success is guaranteed. How do you like that? Okay? So let's go to the homework, which is C12, number 1 through 20 all, and we're just going to do sine and cosine. Okay? Don't worry about tangent. I really just want to get sine and cosine feeling a little cemented with you guys today, and then we'll play tomorrow. I'll do tangent with you tomorrow, and we'll play. We'll play. It'll be so fun. Okay? So 1 through 20, we're doing all of them the same exact way I'm going to show you. So for every single one, we're going to find sine and cosine. And let's keep it in this order just to practice, because that's what you're going to see most often. So listen, guys, you have a key, right? You just filled out these notes. You have a key. Try to keep it away. I'm doing these with you anyway. I want to show you exactly how I do the unit circle. What's going to happen is, as we go through this trig unit, I'll be walking around and helping you at those different times, and you'll be like, wait, I get stuck on this one. Can you help? Wait, what? Or what did I get wrong? So I have to come up with the trig function in my head to help you. So I've had a lot of practice doing this, and I'm telling you the way I do it is very, very, it works great for me, who has a horrible memory, okay? I can't memorize things. I'm horrible at it. I know the unit circle, though. So what you'll see me do is my eyes will go up and to the right. And I don't know if that's a memory thing. I have to ask Mr. Young about that, like something in the brain. But like I see the unit circle in my brain, and I wish you could see inside my brain. But I see it there, and I kind of zero it. I find it, okay? When you say to me, did I get this right, and I'm checking your sine, your cosine, I don't look at it and go, it's right or it's wrong. It takes me 3 to 5 seconds to find it in my brain. That's fast enough, okay? Even 10 seconds is fast enough. But I find it by looking at the denominator. So if you're a denominator of 3, immediately I go pizza, that's the bigger one. Pizza, I don't think Ty understands this, but pizza is the bigger one, meaning I'm jumping up here. Do you get it? No? 1/6 is smaller than 1/3. This angle is smaller than this angle. This piece of pizza is smaller than this piece of pizza. You want the, yeah. So anyway, I see that. I go pizza in my brain. I don't really say pizza, but that's kind of what I'm thinking. And I grab the ordered pair. I know that just by that 3. Okay? That's what I know from the 3. Then I look at the numerator. There's not a difference of 1. This is my chaos. At 5, we go to 7, 11. 5, I go to 7, 11. This is quadrant 4. That helps me know, and you'll see me draw in the air. I'm constantly drawing the coordinate plane. So when I see that, I can't even do it in my head a lot of times. I'll just go right, like positive, negative, so I can easily come up with an ordered pair. It really doesn't take long if you just learn the denominators and the quadrants. So sine is your y value, don't forget that, and cosine is your x value. Good. Okay, let's keep going. I forgot to mention the denominators of 2. They're at the top and the bottom. There's only 2 of them. They're special. Okay, so half of pi is at the top. This is 3/2 or 1.5. 1.5. Okay, so if I see a denominator of 2, I go, oh, that's one of my quadrantals. Let me be careful because she told me everyone makes mistakes with those. Okay, so 3 pi over 2 is at the top. So that's left or right 0, up 1. Right? Sine is y, cosine is x. Yeah. It's at the bottom. I think, honestly, the heat is getting to me. It has been so hot in here today, all day, and has not cooled off. Okay, again, guys, do not get overwhelmed. We're going to get into negative angles in a second, coterminal, they're not even on the answer. You cannot be afraid of the number 6. Pizza. 6 and 3 are pizza. 6 is the smaller one, which means it's the first one. When you see 6, you think, oh, it's the smaller one. So that means it's the first one you come to, right? The smallest ones are here, and they get bigger as you go. So if you memorize this, that our first angle, I'm messing mine all up, I'm going to throw it away, but this and this go together, you can't go wrong. You know the ordered pair just by knowing the pizza thing. And then you go, okay, the numerator is 1 more than the denominator. Without looking at your unit circle, what quadrant is that? Remember the little thing I told you? 1 less, right? Subtract 1 from your denominator here, add 1. This is chaos. It's more than 1 is the difference in all of them. Remember, if this is like a difference of 2 between the two numbers, that was quadrant 4. So quadrant 3, everybody be negative in quadrant 3. Sine of theta is negative 1/2. Cosine of theta is negative square root of 3 over 2. Okay, negative angles. Who cares what it is? We start with a denominator. 3 isn't scary. 3 is the bigger piece of pizza, right? It's further up on the unit circle. That means it starts with the 1/2. Then we worry about the rest of it. Write that down, or at least cement it in your brain. Like I don't. This is not work that you have to show for me. I'm showing you the process I go through, and I don't have to write it down. I can kind of see it in my head and then apply the signs. But until you're comfortable with that, or even when you are comfortable with that, you can write the ordered pair down. Now, here's how you do negative angles. Every single negative angle on the unit circle, I'm going to cover it with this one trick. Go to wherever it's positive, so that would be quadrant what? Where's the positive angle? Quadrant what? 2, right? 1 less on top. And then you cross the x-axis. So 2 pi over 3 is right here. The negative version, you always just cross the x-axis and find his friend with the same denominator. It's exactly makes a straight line. Okay, it works in every single quadrant. If I wanted to know negative 7 pi over 4, I go to positive 7 pi over 4, cross the x-axis. Because it's a distance. So think about it. 2 pi over 3 is a quarter of the circle and a little bit more, or I don't know how you want to think about that. Same thing here. It's a quarter of the unit circle and a little bit more. So it's right here. So negative 2 pi over 3 is actually in quadrant 3. Okay, quadrant 3. Everybody's negative in quadrant 3. That's it. So sine, cosine. No, you don't have to draw the graph. If you read the directions, some of you did. This is all you have to do for the homework. Just exactly what I'm doing. Okay? Let's keep going. 5 is 5 pi over 4. Denominator. The denominator gets me my ordered pair. All of my denominators of 4 are square root of 2 over 2, square root of 2 over 2. The numerator tells me the signs. One more than the denominator. Which quadrant? 3. Everybody's negative in quadrant 3. How are we doing? Anyone finding this easy? Like, this is easy. Anybody? You just don't want to brag, some of you. It should get easy, okay? If you are tuning me out and you're not paying attention, please go back and watch the video. Please. Because you will be lost this quarter if you don't learn the stuff I'm showing you right here. Okay? Because this is going to be the first step in 5 other types of problems. 10 other types of problems. So if you don't know this, you can't get the problem right. Denominator, pizza, smaller piece of pizza. 6 is the smaller one, 1/6. That's the first angle we come to on the unit circle. Remember, the first angle starts with that. The numerator will give me my signs. So remember, go to where pi over 6 is, cross the x-axis. Pi over 6 is right here. Cross the x-axis. 11 pi over 6 and negative pi over 6, they're called coterminal. They share that same spot. They're different angles, but they are in the same place. If you're in the same place, you have the same ordered pair. Oh, I didn't put my negatives on here. Guys, make sure you put those on there. I don't know if this is my copy from this period. Did you guys put negatives on your signs? Sorry if I didn't do it. Apologize. Okay, so quadrant 4, to the right and down, sign is negative. Close to that sign. Okay. Number 7 is 5 pi over 6. Denominator, smaller piece of pizza. That's the first angle we come to. Numerator tells me I'm in quadrant what? If I'm 1 less, 2. Remember, 1 less on top, that's not quite 1, right? 6 over 6 is 1 pi. 5 over 6 isn't quite to the 180, to the half, so we're in quadrant 2. So that's negative, positive. Left and up. Negative, positive. Sign. I'll just do one more with you, because this one is not on the unit circle. Well, let's not even say that. Let's just start with the denominator. You can do it the same way every time. Denominator of 4 is this guy, right? The numerator is not any of them that I recognize, because this is greater than 2 pi. This is off the unit circle, because 8 pi over 4 would be 2 pi. So I have to find its coterminal angle. And if you remember, coterminal last Thursday was add or subtract 360. If adding and subtracting 360 works for degrees, what do you think we add or subtract for radians? What's a full revolution? 2 pi, right? 1 pi is at half of the circle, 2 pi. So in radians, we have to subtract 2 pi, but let's pretend we don't have a calculator, because you might not. You need to make something pi over 4. Well, I want it to equal 2. What numerator gives me a 2 pi here? Yeah. So if the denominator was 3, I'd make it a 6 pi. If it was a denominator of 3 or 6, I'd make it 12 pi. 3 would be 6 pi, whatever. And that gives you 19/3 pi over 4. So they are at the same place on the unit circle. They are coterminal. They share that spot. 3 pi over 4 and 11 pi over 4 are coterminal. They have the same ordered pair. Okay? So quadrant 3. that is cosine, that is sine. Okay? Say it again. Quadrant 2. Right. Sorry, quadrant 2. Right ordered pair. So guys, finish this, practice this, come in with questions tomorrow. We're going to play tomorrow. We're going to have fun with it. I'm going to go over course offerings, like I said. I'm going to give you the tangent values. I'm going to help you with whatever, and we're going to all get a nice pink one, and we're going to fill it in nice and pretty together. Tomorrow would be a good day to bring some colors if you have it, because then you can fill it in nice and pretty like mine. But you don't have to, okay? All right, so let me put the rest of the key up. So the key has tangent on it. I didn't tell you to do tangents. Don't worry about that, okay?